Okay guys, I'm recording as best I can, but I live next to an interstate, so it may be loud at times, but I'm gonna talk to you about H-flip. So that is the one that is like mirroring. And I'm just gonna go through some examples of how I would work this out. So I drew two pictures of two examples, and I'm gonna fill in the total rows and total columns here. So the total rows, we have 6 rows and 4 columns. And here we have 4 rows and 3 columns. And I'm going to use these two examples to talk about two different strategies. So 2 strategies. You would just implement one, but it's like 2 different approaches to this. Okay, so I have 2 examples because one of these has an odd number of columns and one of them has an even number of columns. So essentially we are flipping on these midpoints. So I drew a dotted line, and everything to the right of the dotted line over here is going to go on this side. So a pixel in this column is going to go over in this column. The pixels in these columns are going to go in these columns. So get rid of my scribbles. Okay, so we're going to flip, and then down here, this middle row stays the same. So everything on this side goes over here, and everything on this side goes over here. But the middle row doesn't move. So I just wanted to show you 2 examples. That's, and get rid of my scribbles again. Okay. So I think there are 2 ways you can approach this. One is to take a look at all of the pixels on the left side. So everything to the left of the midpoint column. Goes right. So you could use a swap function, but that just means you only need to swap on this half or go through this half, because once you accomplish the swap, this one will go over here, this guy goes over here. So if I came over on this side and performed swap again, then I'd be swapping back to the original. So I only need to perform the function on one half of my picture. It would take care of the other half. So everything on the left of the midpoint goes right. So we swap. Or you could go row by row. So this row, and then this row, and then this row. And we take every pixel. So this is the OG picture, and this is the new picture. And I'm going to take the last pixel here and print it out first on the new side. And then the second to last here, so I'm going to do that one with dots. That goes here. So I'm going through my vector backwards as I print it out onto the screen, then row by row. So whichever one seems easier. So that one is print out each row backwards. Okay, so in order to do this, you're going to use some of the math that we did with the Cipher Lab, where we're figuring out rows and columns based on a grid number. So whenever I forget how to do this, I just pick an index and then redo the math. So let's pick this one, 16. And you want to try to pick something that is a different row and column. So I know this is row 4, and column 0. And so that way when I do my math, I get a different number for my row and my column. Like picking 1, 1, picking this guy right here wouldn't be a great one to pick to figure math out because the row and column is the same. All right, so if I have, I'm going to call this I for index. If my I is 16, what is the row number and what is the column number? This would be helpful for this strategy, strategy number 1. So what is the row number? I know by the picture it's 4 and 0, but how would I figure that out in my code? Well, if you remember the cipher lab in some of the labs that we did last year, you need to use integer division and mod. So to get my row number, I pass over how many, didn't mean to do, well, that kind of works actually. So I'm going through all of the columns how many times? So I'm going to pass over all of the columns 1 time, 2 times, 3 times, 4 times, and then I'm going to go partially through, but how many complete times do I go all the way through is going to give me my row number. So get rid of there we go. Nope. Okay, so for the row number, we're going to take 16, and if I divide it by the total number of columns, which is 4, 16 divided by 4 is 4. So let's test that with 18, because that should still be 4. So 18 integer division 4, that's still 4. 19 divided by 4 with int division is still 4. And then 20 divided by 4, I get 5. So you can see how this works. Okay, get rid of all this. Okay, so that's my row number. 4. And then column number, that's going partially through the row. So what's my leftover amount? Leftover, think mod. So 16 mod 4 is 0. I haven't gone into like further right at all. So that's my column number. So if I do 17 mod 4, then that's 1, and sure enough, 17 is in column 1. And then 18 mod 4 is 2, 18 is in column 2. So you can see how this works too. All right, so what formula was this? This was for row number. We did, oh, not eraser. Okay, we did I, dang it. I'll zoom back out in just a second, but we did I divided by total columns. And then here we did I mod total columns. Okay, so that was to get the row number and the column number of I. And then if we need to get, let's say we have a row and column and we need to find the index number. So this is have I, and we need row number and column number. And then what if we have a row number and column number, but need I? So what can we do here? So let's say I have row number 2, column number 3. All right, so row number 2, column number 3 is, we can see that's 11 over here. So I know 11 should be my answer. So it's doing this backwards a little bit. And what I need to do is, instead of integer division, to undo this, I do multiplication, right? So what if I take my total columns, which is 4, and multiply that by my column number 3? What do I get? So 4 times 3 is 12. That's a little too far. Okay, so let's try, I go over in row number 2, I complete 2 whole rows. So if I do total columns times row number, then total columns is 4 times row number 2, that is 8. And then how far do we go partially across the row? And that's my column number 3. I go 3 spots across, so plus 3 equals 11. All right, so to put that into an equation, it's total columns times row number plus column number. Okay, so that is where I need I have the row number and the column number. Okay, so these are going to be helpful if you do this method. That's because, let's call this method A and method B. With A, I want to go through my whole picture. So that's for I to the last pixel. So I'm going to hit all the pixels here. And if I is in a column that is less than the midpoint column, then I will do my swap. So I only care about this side, remember? So as I go through my whole picture, so I like loop through here, if I'm on this side, then I want to swap. I don't care if I'm on this side, I'll just skip right over that. So right here, I is in a column less than the midpoint column. I need to know what column I is in, so I can do that by right here. I get the column number. All right, so can I, nope. I want to do that thing where you grab the text and move it, but I don't know if I can do that. Okay, so I wish I could grab text and move it. I'm sure there's a lasso function in here somewhere. Da, da, da. Nope. Nope. Okay, anyway, figure that out later. You're going to calculate I's column number. Obviously, before you do that if statement. Okay, so then you would swap the I and the J, and figuring out the J is also tricky. So I know that let's say this one right here, is 2 away from the midpoint, so I'm going to swap it with this guy over here, which is 2 away. So I need to find this difference. How many columns am I from the midpoint? So that is just the midpoint column minus my I column. But that might be different if I have an even number of columns, so just take that into account. So my midpoint column, when I have even versus odd numbers, might be a little bit different. All right, so some of you all might do that. I'm not going to go into a whole lot more detail because some people might think B is easier. So B is print out each row backwards. So here I'm going to redraw this. And here are my rows. Okay, so as I loop through all of my rows, one by one, I'm going to print out this new image, but I'm going to start at this pixel, and that pixel's going to go here. Then this one and that one's going to go here. This one, that one's going to go here. This one's going to go here, and this one's going to go here. All right, so the way you need to think about that is you're going to go in a loop starting at 0 to total rows. So hit each row up in my loop. And then you're going to want to figure out what pixel number this is. So figure out what your I is. So that's going to be my starting pixel. So over here, 16 was the starting pixel in this row. And so the way we got 16 is I'm going to take my row number 4. We've gone through 4 complete rows. So how many columns are in a row? That's 4 total columns. And my row number is 4. 4 times 4 is 16. Right here, I'm in row number 5. And total columns is 4. I've gone across 4 columns 5 times, so that's 20. Here, I've gone across 1, 2, 3, 4 columns 1 time, so that's 4. So way down here. So what is my I? I'll call this my starting pixel. Sorry, my handwriting is getting worse. And this is going to be this box. And that is my row number times my total columns, as we talked about above. So you know what your row number is because of your for loop, right? You're going through each row, so you should know what your row number is. And then we multiply that by your total column. So that's our starting pixel. And then after we figure out our starting pixel, we're going to go through each column. So for each column, so if I call this R and I call this C, my iterators for each row is going to be R, and for down here it's going to be C. Then I'm going to print out say the old image, and then I'm going to let you guys do the math, but this is simply math to figure out the pixel that we do. So we're going to print out, and instead of print out what we figured out right here, this guy, I want to grab him and I'll put him here. So I want to have this guy get printed. So I'll let you guys figure out this math, But just as a hint, you're going to need the starting pixel, of course. So need that. And you'll be using C. And you'll need some other things, but at least this. So play around with the math, and I highly suggest to write it out. So draw these pictures of what you're doing and make up numbers. So come back up and take a look here. Pick a number and say, okay, I am using this number, and what am I trying to do? And write it out like I did right here or over here. Just take a piece of paper and write it out. You'll save so much time. Okay, so this is going row by row and printing this out backwards. Or we're gonna go through the pixels, all of the pixels, ignore the right side, and on the left side, we'll swap. And then you can print out the new one. Okay, was there anything else that I wanted to tell you? Check, check, check. Okay, so for A, the J you have to figure out. So how far is J from the middle? But all this stuff up here hopefully is helpful and a good reminder. And when you get stuck, just make examples. I tend to make examples where I have both cases of like this midpoint being in the middle, and I use small examples, but large enough where I don't get like off by one issues easily. So I just wanna make them large enough, like these two are large enough. And then if you're trying to do math, like I said, pick numbers where the rows and columns are different, so that way you can distinguish your variables a little bit easier when you go and try to figure out your functions. All right, so once you get H flip written out, then hopefully V flip isn't as bad, because then instead of doing a flip here, we're doing a flip this way. So you can use the same kind of logic, it's just that we have a row as a midpoint instead of a column as a midpoint. So you could do something like strategy A, where I'm gonna go through just the top half here and do a swap. Or you can go through each column and print it out backwards if you want to. I think that this is a little bit easier for me to think about, but this one, so A I think is easier for me to think about, but B is less lines to code. And maybe B is easier for you to think about too, and it's also less lines to code. So up to you. All right, and I think that is all I had for those who I helped today.